Hello, this is Dr. Dan Wedding, and this is DrWedding VB06, Integer Math, Casting, Modulo, and Random Numbers. Integers can't hold a decimal point. They can only hold a whole number. So when an integer is assigned a double, it will round the value up or down depending on what the decimal point value is. On many websites, the rounding rules are listed as: if the decimal point is greater than 0.5, the whole number is rounded up. If the decimal point is exactly 0.5, the whole number is rounded up or down to the even value. If the decimal point is less than 0.5, the whole number is rounded down. These rules are true, but it can be confusing when dealing with negative numbers. When dealing with negative numbers, think about your bank account. Would you rather be $5 in debt or $6 in debt? So -5 is larger than -6. And terms like round down and round up become confusing. To avoid confusion with positive and negative values, it's easier to use these rules. If the decimal point is greater than 0.5, round to the closest whole number. If the decimal point is exactly 0.5, the whole number is rounded up or down to the even value. If the decimal point is less than 0.5, round to the closest whole number. For further clarification, please pause the video to review the examples below. In these examples, int Sam is an integer variable. Casting is when you force a variable of one type into a variable of a different type. There are many different ways to cast a value from one type to another. In this video, we will only cover a few basic methods. To cast a variable, the value being cast is inside a set of parentheses, and the type it is being converted into is in front of it. An example is shown below. Casting rounds down to the nearest integer. Using fix instead of int will truncate or cut off the decimal point. For positive values, int and fix have the same results. For negative values, int and fix give different results. The modulo or modulus function is often called the mod function. The mod function performs an integer division. It ignores the whole number and returns just the remainder. Think of the mod function as a fraction. There is a numerator on the top and a denominator on the bottom. When taking the modulus of a value, assume the denominator is n. The function returns one of n values in the range of 0 to n minus 1. For clarification, please pause the video to review the examples below. If you are confused, the following examples might help you better understand the mod function. These examples are using positive numbers, so mod 2 will always generate one of two values, 0 or 1. Please pause the video and review the following list of examples to help you better understand how the mod function works. In these examples, also using positive values, mod 3 will always generate one of three values, 0, 1, or 2. If you need more clarification, please pause the video and review the following list of equations. The modulus function only works with integers. If you pass the mod function a double, VB will round the double to an integer before it calculates the modulus. When discussing an equation with a mod in it, the denominator is the value that is talked about. So if somebody says mod 0, they mean the denominator of the fraction is 0. Mod 0 is a divide by 0 error. When a negative number is used with the mod function, there is a problem. There's an argument on what the correct answer should be, and different computer languages approach the problem differently. The first argument is the mod function must always be positive. Excel, Python, and a few other languages use this definition. To keep the mod positive, the function calculates the next negative number that is evenly divided by the denominator. In this example, negative 12 is the next negative value evenly divided by 3. Then a positive remainder is added to back up to the original number. From this point of view, negative 10 mod 3 is equal to minus 4, remainder positive 2. So the answer is positive 2. This is correct because 3 times negative 4 equals negative 12. And negative 12 plus the remainder 2 equals the original negative 10. The second argument is the mod function is the remainder, positive or negative. Visual Basic, C, C++, Java, and others use this definition. The mod is calculated the same way it is for positive values. It does not matter that the remainder is negative. From this point of view, negative 10 mod 3 is equal to negative 3 remainder negative 1. So the answer is negative 1. This is also correct because 3 times negative 3 equals negative 9. And negative 9 plus the remainder of negative 1 equals the original negative 10. These examples demonstrate that mod 2 with negative numbers will always return one of two values, 0 or negative 1. Please pause the video and review the following list of equations to help you better understand how mod works with a negative number. These examples demonstrate that mod 3 with negative numbers will always return one of three values, 0, negative 1, or negative 2. Please pause the video and review the following list of equations if you still need help. Real random number generators are complex pieces of equipment that monitor atmospheric noise, background radiation of the universe, or some other natural random process. Because computers, laptops, phones, and other electronics do not have this capability, they must rely on pseudo-random number generators. Pseudo-random number generators are just large files of random numbers that were copied from real random number generators. Your computer or laptop has a pseudo-random number generator and not a random number generator. The rand function will pull the next value out of the pseudo-random number file. The function rand will return a value that is greater than or equal to 0 up to a number less than 1, but never equal to 1. An example of how to use the rand function is shown below. In order to generate a random integer value in a range, use the equation shown below. This equation will generate an integer value that is greater than or equal to low val and less than or equal to high val. This equation, like all of the equations in VB, follow the order of operations. The following examples will use the integer range equation to generate a series of ranges. If you need help understanding how to use this equation, please pause the video and review the examples. If you're confused on how this equation generates a random range, please pause the video and go through this detailed explanation. As stated before, VB uses a pseudo-random number generator that is essentially a file of random numbers. If you use the function rand to get 5 values, and your neighbor does the same thing, you will both get the same numbers in the same order. If you run the program 50 times in a row, you will always get the same random numbers in the same order. In fact, you might even get the numbers shown below. Non-random random numbers is a very big problem. To solve this problem, the function randomize was created. Think of it like an egg beater that will mix up the file before you use rand. Randomize should be run one time at the start of the program. The best place to put this function is in the subroutine form load. There's a lot of information that was covered very quickly. Let's go to an example and explain these in detail. I have already opened up a new project named VB06. I've also generated a form. This form has an input text box named txt_dblin, a button named btn Int Math, an output text box named txt_int_out, and a text box at the bottom of the form for printing out error messages named txt_error_msg, or error message. To open up the code portion of the project, I will double-click on the button. This will bring up the code portion that will run when button Int Math is pressed. As always, I will start with comments at the top of the program to explain what the program is doing. I will also need to generate some variables. I will use the dim command to generate 6 integers and the dim command to generate 2 double variables. The first portion of this program will be used to demonstrate the difference between rounding, casting as an integer, or casting using fix. I will start in the subroutine with a try catch. Inside the catch, I will print out any error messages. You should understand everything on the screen at this point. If you do not, you should go back and review the previous videos. Now that the skeleton code has been set up, I can convert a double into an integer using the 3 methods discussed earlier. To save time, I have already written the demonstration code. The first line of code copies the information on the text box into a double variable called dblx. The next line of code copies the double variable into an integer called int a. This will allow Visual Basic to round the value. The information is then displayed on the output text box. The double variable is then copied into a second integer called int b using the int command. Int will always round down. This information is again printed to the output text box. Note that it's using append text this time. Append text is being used so that the previous information is not erased from the text box. In this line of code, dblx is cast into int c, this time using the fix command. The fix command will truncate the decimal points. This means it will just cut them off and throw them away. It should be noted that for positive values, int and fix will result in the same value. The information is again printed to the text box. Now that all 3 methods have been demonstrated using a positive value, they will again be demonstrated, but this time with a negative value. dblx will be multiplied by -1 to generate a negative value called dbly. As before, the double will be copied into an integer. the rounding will be performed by Visual Basic following the rules discussed earlier. The information will again be printed to the text box. The double will be cast into another integer using int. The information will be printed to the text box. The negative value will be cast into an int named int f, this time using fix. It should be noted that for negative values, int and fix will generate different values. And finally, this information will also be printed to the text box. Let's run the program and see what happens. Let's start with a decimal point that is greater than 0.5. When Visual Basic was allowed to round, it rounded up. 2.8 is closer to 3, so it rounded up. When casting is done with int, the value is always rounded down. Therefore, 2.8 was rounded down to 2. Fix will always truncate or just remove the decimal point. So the 2.8 became 2 because the 0.8 was removed. Again, for positive values, int and fix will result in the same answer. When the value is converted to a negative number and then passed into an integer, the minus 2.8 became minus 3 because that's the number it was closest to. When the negative value was cast into an integer using int, the number was rounded down. Negative 3 is smaller than negative 2. When the value was cast using fix, fix just truncated or removed the 0.8. As you can see, when you're using a negative number, int and fix will give you different values. Let's change the decimal point to 0.5 and see what happens. When allowed to round, Visual Basic took the 2.5 and rounded down to 2 because 2 is an even number. Casting, using int, rounded down to 2. Casting, using fix, just truncated or removed the 0.5, also resulting in 2. When negative 2.5 is rounded, it was rounded to minus 2, the closest even value. When minus 2.5 was cast using int, it went to minus 3. Minus 3 is smaller than minus 2. It rounded down. When minus 2.5 was cast using fix, it just truncated the 0.5, resulting in minus 2. Now let's see what happens when the decimal point is less than 0.5. When 2.1 was rounded, it was rounded down to 2. When 2.1 was cast using int, it was rounded down to 2. When 2.1 was cast using fix, the 0.1 was removed. When minus 2.1 was rounded, it was rounded to minus 2, the closest whole value. When minus 2.1 was cast using int, it was rounded down to the next value. Keep in mind, minus 3 is a smaller value than minus 2. And when minus 2.1 was cast using fix, fix will just truncate the 0.1, resulting in minus 2. In this final example, I'm going to use 3.5. On this example, I'm only going to focus in on the rounding. You'll notice that in this example, it rounded up to 4. When the entered value was 2.5, it rounded down to 2 because 2 was the even number. When 3.5 is entered, it rounds up to 4 because 4 is the even number. Negative 3.5 also rounded to negative 4, which is an even number. So when the decimal point is 0.5, it will always round to the nearest even number. That means sometimes it'll round up and sometimes it will round down. Now let's investigate the modulus function. To save room on the screen, I'm going to press the minus sign right next to the try and minimize this portion of code. The subroutine is still there, it's just minimized. Next, I'm going to add to the form so we can test the modulus function. I've added 3 more text boxes and a button so that I can demonstrate the mod function. I'll double-click on the mod button and open the code that will run when button mod is pressed. In this example, it really doesn't matter if I'm using a class variable or a local variable, so I'll just use a local variable as a review. I'll create 3 local variables, one for the numerator, one for the denominator, and one for the answer. And I will also insert the try catch that I do automatically. When the button is pressed, I'll read in the numerator and then the denominator, perform the mod function, store the answer in int answer, and then print the result to the text box. Again, int num will receive the information in the text property of the text box text numerator. The integer int denom will receive the text property of the text box text denominator. Int ans will receive the answer when I perform the modulus function. Remember, it's just like a fraction with a numerator and a denominator. Int answer will receive the remainder, not the whole number, but the remainder when the numerator is divided by the denominator. Then the answer will be printed to the text box. It's always a good idea to comment your code. Now let's run the program and see what happens. Let's choose a numerator. For example, 22. Next, we'll choose a denominator. For example, 3. 3 goes into 22 7 times with a remainder of 1. So the answer will be 1, the remainder. If I take 22 and make the denominator equal to 4, 4 goes into 22 5 times with a remainder of 2. 5 times 4 is 20, plus 2 more is 22. Let's choose 13. 13 will generate a remainder of anywhere between 0 and 12. 13 goes into 22 1 time, with 9 as the remainder. If I choose 11, 11 goes into 22 2 times evenly. There is no remainder. So in this example, the mod will be 0. This gets a little confusing when we start dealing with negative numbers. If I start out with negative 22, again, 11 goes into negative 22 negative 2 times with 0 remainder. However, if I were to choose 5, 5 goes into 22 4 times with a remainder of negative 2. Negative 4 times 5 is negative 20, and the remainder will be negative 2. Many programs will force the mod to always be positive. They won't just take the absolute value of the answer, they'll calculate it in a different way. Excel would have rounded up to negative 25. 5 would have gone into negative 25 5 times and then backed up 3 spaces to get to the negative 22. So Excel would have given the value of positive 3. Negative 5 times 5 is negative 25, plus the remainder of positive 3 results in the original negative 22. The code written behind this button is very short and very simple. If you're still confused, you should be able to type it in and run various scenarios on your own to predict what the answer will be. Lastly, we're going to go over an example using random numbers. As before, I will minimize the try, clean up the screen, go to the form, and I will add some extra objects so that I can demonstrate random numbers. Now that I've added these objects to the form, let's double-click on the button and open up the code. Like always, I'm going to start with a try-catch. First, I'm going to simply use RND to remove the first value from the pseudo-random number generator and put it out on the text box, text rand out. As previously discussed, because this is a pseudo-random number generator, it's just a file of random numbers. Therefore, you'll always get the same numbers in the same sequence. Let me demonstrate. Point 70. Point 70. Point 70. To avoid always getting the same random numbers in the same order, we need to mix up the random number file. To do that, go to the form and double-click on the form itself. This will open up a subroutine called form load. This subroutine will only run one time when the form initially loads. Inside of form load, type randomize. And that's it. Now when you use rand, you'll get different numbers every time you run the program. You can use rand as many times as you wish. For example, rand will return a value between 0 and less than 1. If you need a value in an integer range, like a number from 1 to 10, or a number from 5 to 13, you will use the equation that was shown in the notes earlier. Let's demonstrate this code. When I press the Get Random Number button, two values will be printed to the two text boxes. The first text box will be a raw value from the pseudo-random number generator. It is only showing 2 decimal places. This is because the text box is not large enough to display anymore. If I were to change the size of the text box and make it larger, you would see more decimal points. The second random number is an integer in the range of 1 to 10. I hope this video was helpful in understanding casting, integer math, the mod function, and random numbers. In review, a double can be copied into an integer as shown below. When a double is copied into an integer, it is rounded by VB using the following rules. If the decimal point is greater than 0.5, round to the closest whole number. If the decimal point is exactly 0.5, the whole number is rounded up or down to the even value. If a decimal point is less than 0.5, round to the closest whole number. Casting allows you to decide how to convert one value to another, instead of letting VB choose how to convert the value. An example of casting with int is shown below. An example of casting with fix is shown below. When casting with int, the value is always rounded down. When rounding a negative value down, the whole number will increase because the value is becoming more negative. An example of casting a positive and a negative value are shown below. When casting with fix, a decimal point is truncated or cut off. An example of casting a positive and negative value are shown below. The mod function is an integer division that returns the remainder instead of the whole number. All languages agree when dealing with positive values. If a value is divided by a number, n, for example n equals 8, mod will return one of n values, one of 8 values, in the range of 0 to n minus 1, 0 to 7. Examples are shown below. Some languages disagree when dealing with negative values. Some languages enforce a rule that the mod must always be positive, while other languages, such as VB, allow a negative answer. An example of how VB deals with a negative value in the mod function is shown below. An example of how other languages and programs deal with a negative value in the mod function are shown in the examples below. The function randomize will prevent the pseudo-random number generator from returning the same values in the same order every time you use a random number. Randomize must be run once and only once before you use the random number generator. The best place to put randomize is inside of the form1 load subroutine. To generate the form1 load subroutine, double-click on the form. This function will generate the next value from the pseudo-random number generator. Rand will return a value in the range of 0 to less than 1. If you want a random value in an integer range, use the following equation. Note, int can be used in place of fix in the equation above. If you find these videos useful, please like and subscribe. It is the only way I can continue to make these videos.